Welcome to another deep dive. This time into a project that's really gonna, I think, reshape how we see the universe. It's called the Nancy Grace Roman Space Telescope.
Oh, wow.
And, imagine having a time machine, but not to travel through time,
Right.
but to see across vast distances, peering back to the universe's earliest moments. That's what we're talking about here. Our source today is a recent NASA press release, hot off the presses, about the exciting progress on this remarkable telescope.
Yeah,
You ready to explore this?
absolutely. It is an incredibly exciting time for astronomy.
Yeah.
Roman is set to launch by May 2027,
Wow.
and it builds upon the incredible work of Hubble and James Webb, but takes things even further.
I keep hearing how Roman is next generation.
Yeah.
What makes it so special?
Well, one of the most remarkable things is Roman's stability.
Okay.
Imagine a telescope so steady that it makes a surgeon look jittery.
Oh, wow.
Roman is designed to be at least 10 times more stable than Webb
Okay.
and 100 times more stable than Hubble.
I'm picturing that, and it's impressive. Why is that kind of stability so important when we're talking about something that's billions of light years away?
Well, that stability is key for making extremely precise measurements.
Right.
Take dark energy, for example.
Okay.
It's this mysterious force that's thought to be causing the universe's expansion to accelerate.
Right.
But we need to measure the distances to faraway galaxies with incredible accuracy to understand how it works.
Oh, okay.
And that's where Roman's rack-solid stability comes in, allowing for measurements that just wouldn't be possible otherwise.
So it's like having a ruler that can measure billions of light years.
Right.
Except the ruler itself has to be unbelievably still.
Exactly.
That's incredible.
Yeah,
But it's not just about stability, right? Roman is also known for its speed.
that's right. Roman can map huge portions of the sky 1,000 times faster than Hubble while maintaining that same sharp image quality.
Okay.
This speed allows us to create larger, more detailed maps of the universe, giving us a much richer data set to work with.
Okay. It seems like there are going to be some pretty incredible images coming from this thing.
Absolutely.
Speaking of seeing things, tell me about the instruments on board.
Okay.
I know there are two, right?
Yes, Roman has two primary instruments, the wide field instrument and the coronagraph instrument.
Okay.
The wide field instrument is a 300 megapixel infrared camera that will give us panoramic views of the universe.
Okay.
Think of it like taking high-definition wide-angle shots of a galaxy.
That's going to be pretty spectacular, to say the least.
Oh, yeah.
And what about that coronagraph instrument? What does
Yeah.
that one do?
This is where it gets really exciting, especially if you're interested in exoplanets.
Okay.
The coronagraph instrument is designed to block the glare of stars, allowing us to directly image exoplanets orbiting those stars.
So instead of just inferring that a planet is there based on how its star wobbles or how the light dips, we're going to be able to actually see the planet itself.
Exactly. It's a huge leap forward in exoplanet research.
Yeah.
Think about it. We'll be able to study their atmospheres, look for signs of clouds or even oceans, and maybe even find planets that resemble our own Earth.
Wow, just thinking about that gives me chills.
It's amazing.
And I know we'll be diving into this more later, but can you give us a sneak peek at what the big scientific goals are for Roman?
Sure.
What kind of mysteries are we hoping to solve?
Well, Roman is designed to tackle some of the biggest questions in astrophysics. Dark energy, dark matter, exoplanets, even the formation and evolution of galaxies.
Okay.
We'll be able to study billions of galaxies across cosmic time, giving us a kind of movie of how galaxies have changed over billions of years.
Okay.
It's truly revolutionary.
It's incredible to think that one telescope can do all of that. It's like having the ultimate multi-tool for exploring the universe.
It really is. And it's not just about collecting data. It's about what we can do with it.
Right.
Understanding these fundamental mysteries helps us understand our place in the cosmos.
Right.
It gives us perspective and reminds us of the vastness and wonder of the universe we inhabit.
So it's not just looking out into space, it's looking inward at ourselves as well.
Absolutely. And who knows what we'll find.
Yeah.
The possibilities are truly mind-boggling.
It sounds like we're on the cusp of a new era of discovery. So much to unpack and explore.
Totally.
Let's take a closer look at these science goals, shall we?
Let's do it.
All right, so we've established that Roman is this incredibly powerful telescope, but I'm really curious to dive into the specifics.
Okay.
You mentioned dark energy. What exactly are we hoping to learn about this mysterious force?
Well, Roman's going to help us create this 3D map of the universe,
Okay.
showing not only the positions of galaxies, but also their distances from us.
Okay.
And by tracking how these distances change over time, We can measure the universe's expansion rate with incredible precision.
So it's like creating a cosmic rewind button, letting us see how the expansion has changed over billions of years.
Exactly, and that history of expansion is key to understanding dark energy.
Okay.
Right now, one of the biggest questions is whether dark energy is a constant force,
Right.
or if it changes over time.
Yeah.
Romans measurements could provide the answer,
Right.
which has huge implications for the ultimate fate of the universe.
Okay, so the stakes are pretty high.
Yeah.
What about dark matter? I know it's invisible, so how do you even begin to study it?
Right. Well, Roman will be using a technique called weak gravitational lensing.
Yeah.
It's a bit complex,
Okay.
but fascinating. Essentially, massive objects, including dark matter, can warp the fabric of space-time.
Wait.
And as light from distant galaxies travels through this warped space, it gets bent, a bit like looking through a distorted lens.
So we're not actually seeing the dark matter itself, but we're seeing how it affects the light coming from behind it.
Right. By carefully analyzing these distortions, we can map the distribution of dark matter throughout the universe.
Oh, okay.
And Roman's wide field view will allow us to map this distribution on a larger scale than ever before, revealing this intricate cosmic web of dark matter that holds galaxies together.
It's like having X-ray vision for the universe, except instead of seeing through objects, we're seeing the invisible by how it bends light.
Yeah, exactly.
Okay, let's switch gears a bit and talk about those exoplanets.
Okay.
We touched on Roman's ability to directly image them earlier,
Right.
but what can we actually learn from a picture?
Well, direct imaging is a huge step because it allows us to study exoplanets in ways that were impossible before.
Oh.
For example, by analyzing the light that passes through an exoplanet's atmosphere.
Okay.
I can identify different molecules present, like water, oxygen, or methane.
So we can tell what kind of atmosphere an exoplanet has just by looking at the light passing through it.
That's right.
That's incredible. And wouldn't that give us clues about whether a planet could support life?
Exactly. Certain molecules are considered biosignatures, meaning they are strong indicators of biological activity.
Right.
And finding those in an exoplanet's atmosphere would be incredibly exciting.
Wow. We're not just talking about finding exoplanets anymore. We're talking about analyzing their potential for life. That's a whole new level. But we also mentioned galaxies.
Right.
How does Roman fit into that?
Well, Roman's wide field view and sensitivity to infrared light make it an incredible tool for studying galaxy formation and evolution.
Okay.
Remember, when we look at distant objects in space, we're actually looking back in time because the light from those objects has taken billions of years to reach us.
So the farther we look, the farther back in time we're seeing.
Precisely. With Roman, we can observe galaxies at different distances, which means we can study them at different points in their evolution.
Oh, wow.
We can see how galaxies have changed over billions of years, how they've interacted with each other, and how the supermassive black holes at their centers have influenced their growth.
It's like creating a cosmic photo album showing snapshots of galaxies at various stages of their lives.
That's a great way to think about it. And by studying this photo album, we can learn more about the processes that have shaped the universe as we know it.
Okay, my head is spinning a little bit with all of this amazing
I
stuff. But I love it. So Roman is going to help us with dark energy, dark matter, exoplanets, and galaxies.
Yeah.
Is there anything this thing can't do?
Well, it's truly an incredible instrument, and I think what's most exciting is that we don't even know all the questions. Rome will help us answer new discoveries, often lead to new questions that we hadn't even thought of before.
It's like opening a door to a vast, unexplored landscape
Yeah.
and not knowing what wonders await us.
Exactly. But while we might not know all the answers, we can speculate about some potential breakthroughs.
Okay, tell me more. What are some of the holy grail discoveries that scientists are hoping Roman will make? All right, we've been talking about all the incredible science Roman is going to do, but I'm curious what makes this telescope so special from an engineering perspective. It's not just another telescope, right?
Oh, absolutely not. Roman is packed with cutting-edge technology, starting with its 2.4-meter primary mirror.
Okay.
To put that in perspective, that's about the height of a basketball hoop.
Wow.
This thing's massive.
I can only imagine the challenges of building something that large, especially when it needs to be so incredibly stable.
Yeah, it's a huge engineering feat.
Yeah.
Roman's structure is made from super strong, lightweight materials.
Okay.
And the whole design is focused on minimizing vibrations.
Okay.
Plus, it uses gyroscopes and reaction wheels.
Oh.
Kind of like a high-tech balancing
Yeah,
system to
fun.
keep it pointed perfectly at its target.
So even though it's hurtling through space, it can stay incredibly still and focused.
Yeah, it's incredible.
That's amazing.
Right.
But a big mirror is only part of the story, right?
Right.
What about the other components?
Roman's optics are state-of-the-art. The mirrors are polished to an incredible smoothness, minimizing any distortion.
Okay.
And they're coated with special materials that maximize light reflection.
Right.
Then you have the detectors.
Yeah.
These are incredibly sensitive instruments designed to capture even the faintest light from distant objects.
So it's not just about seeing more of the universe. It's about seeing it with the clearest possible view and capturing every photon we can.
Exactly. Every piece of Roman, from the mirror to the detectors, is designed to push the boundaries of what's possible.
Wow.
And then there's the software.
Oh, yeah. The software. I imagine that plays a pretty important role in something this complex.
It's the brains of the operation.
Yeah.
Roman software controls everything, pointing the telescope, collecting the data, and even processing it.
Wow.
We're talking about sophisticated algorithms designed to sift through massive amounts of information and extract the most meaningful scientific insights.
It's like having a team of invisible scientists working alongside the telescope,
Right.
making sure we get the most out of every observation.
That's a great way to put it. And the software can be updated and improved over time.
Oh, okay.
So as we learn more and develop new techniques, Roman will become even smarter and more capable.
It's like giving the telescope a brain upgrade.
Exactly.
Okay, so we've got this amazing piece of hardware, incredible software, and all these groundbreaking science goals. But actually building and launching something like Roman,
Right.
that must be a monumental task.
It is. We're talking about a massive collaboration between thousands of scientists, engineers, and technicians from around the world.
Wow.
The level of precision and expertise required is simply astounding.
I can only imagine the challenges from designing those ultra-precise components to ensuring they can withstand the harsh conditions of space.
And then there's the launch itself, making sure everything goes perfectly to get Roman safely into its final orbit millions of miles away.
Right.
There's no room for error.
It's a testament to human ingenuity, and our relentless drive to explore it makes you realize just how much we can achieve when we work together towards a common goal.
It really does. Roman is a symbol of that collective spirit of exploration and discovery.
You know, as we wrap up this deep dive, I'm feeling a sense of awe and anticipation, awe at the incredible technology and the dedication of everyone involved, and anticipation for all the amazing discoveries yet to come.
I couldn't agree more. And I think it's important to remember that Roman is more than just a telescope.
Right.
It represents hope, inspiration, and the power of human curiosity.
It shows us that even in the face of immense challenges, we can achieve extraordinary things when we set our sights on the stars.
And who knows what awaits us out there. Maybe Roman will finally reveal the nature of dark energy and dark matter, or perhaps it will capture an image of an Earth-like planet with signs of life.
Wow.
The possibilities are endless.
It truly is a thrilling time to be alive and to witness this new chapter in space exploration unfold. So to all our listeners out there, I encourage you to follow Roman's journey. You can find all the latest news and updates on NASA's website, and you can even see stunning images and videos of the telescope as it comes together.
And remember, the cosmos belongs to everyone, whether you're a scientist, an engineer, or simply a curious soul. Never stop looking up at the stars and wondering what's out there.
This deep dive has been an incredible journey, and I can't wait to see what mysteries Roman helps us unravel in the years to come.
Until next time, keep exploring.
Clear skies.